Imagine this: New York City, a normal day like any other. People rushing through Times Square, taxis honking, the hum of a city that never sleeps. And then, out of nowhere, the ground starts to shake. But this isn't just any earthquake. An earthquake so powerful it could rip apart continents, boil the oceans, and possibly just vaporize the entire planet. But before we get ahead of ourselves, let's talk about the Richter scale. Most of us are familiar with earthquake magnitudes somewhere between 3 and 9. Maybe you've even felt a minor quake yourself. Your windows rattle, your coffee spills, and you accidentally hit the subscribe button. And since 10 is a nice round number, a lot of people assume the scale stops there. But it doesn't. In fact, the Richter scale has no upper or lower limit. The scale is logarithmic, meaning each step up is 10 times stronger than the last. Theoretically, an earthquake could keep increasing in magnitude until it destroys the very thing it's shaking. A magnitude 9 earthquake already alters the rotation of the Earth. In fact, both magnitude 9 plus quakes in the 21st century, the 2004 Indian Ocean earthquake and the 2011 Japan earthquake, actually shifted the planet's axis and shortened the length of a day by fractions of a second. That's right, these quakes were so powerful they physically changed time. But what if we went even further? To get to a magnitude 10, we'd need a fault line stretching over 3,500 kilometers. That's about the distance from New York to Los Angeles. A magnitude 11? The fault would have to go halfway around the planet. You're basically breaking continents apart. But what happens if we keep going? A magnitude 15 earthquake wouldn't just knock down buildings or split highways. It would be so powerful, it would boil away the oceans. That's right, the entire water supply of the planet would just disappear. A magnitude 18 earthquake would release nearly 1032 joules of energy. That's about the same amount of energy it takes to hold the Earth together. This would be the equivalent of the Death Star blowing up Alderaan. A magnitude 24 would release as much energy as detonating an entire Jupiter's worth of hydrogen bombs at the same time. That's not even theoretical. We know that super heavy neutron stars experience quakes at this level. And if we push it even further, a magnitude 25 earthquake would straight up destroy the sun. So yeah, probably not something we need to worry about, at least not in our solar system. Okay, so we've obliterated Earth several times over. Let's take a step back and talk about the opposite end of the scale. It turns out the scale does go below zero. A magnitude 1 earthquake is about as powerful as dropping a tank from 10 meters onto the street in front of your house. A magnitude 0? That's roughly equivalent to a car slamming into a tree in your backyard at 10 kilometers per hour. And from there, things get weird. Magnitude -1 would be like a deer running into a wall. -2, a cat jumping down from that wall. -3, a toddler tipping over a glass. -4, just dropping a penny. -5, pressing a typewriter key. -6, clicking a computer mouse. -7, a feather settling on top of it. -8, a grain of sand landing on that feather. And by magnitude -15, just that grain of sand slipping off again. So, at least on one end of the scale, the world doesn't end in fiery destruction. But what if the world did end? How long would the lights stay on if humans disappeared? Let's imagine for a moment that every single human being on Earth simply vanished. 1 second, we're here, and the next, we're gone. The skyscrapers remain standing, the roads are still paved, and our machines keep humming along, oblivious to the fact that their creators are no longer around to maintain them. At first, it would seem as if nothing had changed. The lights would still be on, cities would remain illuminated, their neon signs flickering in the night. The glow of countless homes and businesses would still shine brightly, giving off the illusion of life. But this illusion wouldn't last long, because without humans, the systems that power our world, our electrical grids, power plants, and maintenance networks, would start to break down almost immediately. The question is, how long before the entire world goes dark? To understand how long the lights would stay on, we need to start with the biggest source of artificial illumination, the power grid. Most of the world's electricity comes from fossil fuel plants, coal, oil, and natural gas. These plants aren't designed to run forever without human intervention. They rely on a steady supply of fuel and routine maintenance. The moment humans disappear, the supply chains that keep these plants running grind to a halt. At first, the plants will keep going on autopilot. Backup fuel reserves would keep them running for a few hours, maybe days. But without human workers to control energy distribution, minor issues will snowball into major failures. One plant will go offline, shifting the energy load onto others. This extra load will cause more plants to fail. The entire system will collapse in a cascading blackout. Within a matter of days, the major power grids will be completely dark. While most of the world goes dark, a few power stations will still be holding out. Dams like the Hoover Dam don't need fuel. As long as the river keeps flowing, the turbines keep spinning. But the electricity needs somewhere to go. When the power grid collapses, hydroelectric dams will be generating electricity with nowhere to send it. Modern dams have safety mechanisms to shut them down in these cases. But without human oversight, it's likely that some turbines would keep running for years, unchecked and unregulated, until sediment clogs the intake valves, or erosion weakens key components. Nuclear power plants are built for long-term operation, but they aren't designed to run forever without maintenance. The moment something goes wrong, like a sensor failing or a coolant leak, the system automatically shuts down. Some reactors, however, could keep running for a while. If a reactor core settles into low power mode, it could theoretically sustain itself for decades. Nuclear fuel is incredibly energy dense. One uranium fuel pellet, about 1 centimeter in length and diameter, contains roughly the same amount of energy as 4 tons of coal. But while the fuel might last, the infrastructure won't. Reactors require constant cooling to prevent overheating, and many rely on electric pumps to circulate coolant. With the grid offline, emergency diesel generators would kick in until they run out of fuel. In the best-case scenario, a few nuclear reactors could still be operational years later, their dim control room screens faintly glowing in the darkness. Or there could be catastrophic meltdowns, releasing radiation into the wild with no one left to stop it. Wind power might last the longest. Unlike nuclear and hydro, wind turbines don't need human intervention, at least not immediately. A few might continue spinning for decades. Eventually, though, they too would fail. The gearboxes need lubrication, and once that oil dries up, the turbines will seize and fall silent. And then there's solar power. Most solar-powered infrastructure wouldn't last long. Dust, corrosion, and degraded batteries would render most solar installations useless within a few decades. But some systems might last centuries. Remote solar-powered beacons and satellites could keep running for 100 years or more. As long as the panels stay relatively clean, their circuits remain intact, and nothing knocks them down. They'll keep generating small amounts of electricity. At this point, we're talking about isolated, flickering LEDs, the final glimmers of human civilization. But what if we're thinking too small? What if there was another kind of light that could outlast all of these? Even after the last solar-powered LED flickers out, there will still be one final light source. Buried deep in underground storage facilities, forgotten and sealed away, sits radioactive waste. Nuclear fuel gives off a faint, ghostly blue glow caused by Cherenkov radiation. It's the same eerie glow seen in the core of a nuclear reactor. And unlike everything else on this list, this glow doesn't need maintenance. Cesium-137, one of the most common nuclear waste products, has a half-life of 30 years. That means, after 2 centuries, it would still be glowing at 1% of its original brightness. And uranium-238 can stay radioactive for hundreds of thousands of years. So, long after the last streetlight dies and the dams get flooded, the final remnants of human civilization will still be glowing, forgotten except by alien archaeologists who unearth their remains thousands of years later. And that brings us to the ultimate question. What will be the last trace of our civilization? What will be the final, undeniable piece of evidence that humanity ever existed?